Okay, hope I'm audible. So just give me a moment. I'll share the presentation. Once you are able to see the presentation, just text me in chat box, yes, audible and visible. You just text in chat box AV so that we can continue. Can you please check now and let me know? ఇప్పుడు okay. Yes, ఇప్పుడు okay. Thank you. Okay, fine. So now, yeah. Thank you so much. So now I'll unmute. So today we are going to discuss about the electrical hazards. So yesterday we have covered static electricity and what are the various the processes or activities which is contributing in process of generating static electricity, and we have seen how we can control it and what is the protocol, or I can say the hierarchy of controls. Then in the second class we have discussed about lightning arresters, why it is required and what is the importance of lightning arresters and how it gets discharges. And we have seen the what are the components which will involve in the lightning arrestor system. And also I have given a reference for the two standards. One is IEC and also Indian standards for the more detail. So today we are going to talk about the electrical hazards. Okay, what I do is I'll just take the insights of new people. I think most of them are working in industries. So today, any thoughts? What will be the different types of hazards with respect to electrical? Any idea? You can unmute and talk now.
Electrocution.
Okay, electric shock. Yes, electrocution.
Electric shock.
Electrical burns.
Okay, burns.
Fire.
Okay, fire. Any other?
Sparks.
Okay, spark which will leads to fires. Yes. Even arc flash. Any other? Okay. There are indirect, even fall from height due to the electric shock. That is also one of the potential hazard with the electricity. Maybe because you are working in height, you may got an electrocution or you may got electric shock. It may throw you out. Or it may pull away from that. So that is also one of the potential hazard with respect to electricity. Okay. Now we'll see what exactly, and maybe we have. If you have any question, you can text me in the chat so that we can discuss. Now we'll see what is the usefulness. Before going to discuss about the hazards, or which I can say the bad about electricity, we will discuss about what is the good about electricity. Okay, the good thing is, with the beginning of 20th century, electricity entered into the, and today it has changed the whole industrial, economic, and the social picture. So even though if you compare, we don't think about 20th century and all, if you can see our span, we are in 90s. I mean, I am born in 90s. So if you see from 90s to 2023, 1990 to 2023, there is a huge change in part of using the electricity. Maybe when I was a kid, there is no electric rice cookers. When I was a kid, the what do you call? There is no charged or battery driven lights. Or when I was in a kid, there is no LED. When I was in a kid, there is no the population of washing machines. And when I was a kid, there is no the mobiles or that much this thing. These all are the interventions or the usage or the benefits which electricity brings into the social picture, which means how people are getting used or helped for their day-to-day lives. Even juicers or uh, dishwashers, all these are not there. So if we see a faster and mass production and also advancement of life could or not have been possible without electric power, which has become a major source of prime movers for the most of the missions. This is also one of the things. If there's no electricity, so if you see pre-industrialization, it is completely depends on the human energy. ఎప్పుడైతే మనకి ఇండస్ట్రీస్ రాకముందు అంటే ఇండస్ట్రియలైజేషన్ జరగక ముందు, సో యాంత్రికంగా మనము డెవలప్ అవ్వక ముందు అంటే మనుషులు వాళ్ళ యొక్క శక్తి మీద డిపెండ్ అయ్యి మనకి ఈ ఫ్యాక్టరీస్ అనేవి నడిచేవి. వన్స్ ద ఇండస్ట్రియలైజేషన్ స్టార్టెడ్, వెన్ ద పవర్ హ్యాస్ బీన్ కమ్ ఇన్ టు ద పిక్చర్ ఇన్ మ్యానుఫ్యాక్చరింగ్ ప్రాసెస్, it is completely driven by the electric power of the prime movers. Whatever the prime mover in the sense, the major, the driven, the machines which will convert the raw material into the final product or intermediate products. Electricity has eliminated many areas of the life like industrialization, lights, sound, or even speakers, or heating, cooling, education, computer, transportation, and enormous essential human services. So even electric bus, whenever in kid there is no electric bus, there is no electric car. I mean, even I can say there is no power bank, I have not seen. So all these things have been come into the picture with the help of this electricity. Its domestic use are day by day it is increasing. A variety of kitchen appliances, as I given an examples, and other electrical equipments have been touched the almost every corner of the modern life. Not only in the modern life, even now you can see all kind of electrical appliances in the villages also, because of the support which the e-commerce are giving. So they can come and deliver in the even the remote locations now. Previously it is confined with the cities. Now they are delivering in the villages as well, in the remote locations also. So, but it is in a handle with a care, but it is to be handled. So, ठीक है, इतना अच्छा कर रहा है करके, we should not take the third idea. We should be cautious with that. It is dangerous because its contact with human body is dangerous and also proves fatal if not properly controlled by the engineering and also manual precautions. If you're not handling it properly, it may lead to death also. Fatal అంటే ఏంటంటే చనిపోయే అవకాశం ఉంది. సో ఎంత ఉపయోగం ఉందో అంతే రకంగా మనం దీన్ని ప్రాపర్గా జాగ్రత్తగా దీన్ని యూజ్ చేసుకోవాలి, లేదంటే మనకి షాక్ తగిలి చనిపోయే ఛాన్సెస్ ఉంది. So if you see the accidents and hazards, the loose electric wires or cables laying on the road or crushed by the moving vehicles, allowing them in a tapped condition, create an hazard. Such condition should be avoided. A major thing is, especially in construction industries or anywhere, wherever there is a movement of the vehicles or there is a movement of any equipment or material, there the cable should not be run through. So while it is interacting with the cable, it is gets damaged. If you see the studies, how the incidents have been happened due to the overload and poor arrangement, 36%. People used to overload the circuits, even though in our home also we'll get a multi-socket, we'll put mobile, laptop, TV, power bank, and also water heater and also iron box, everything to the one socket. So what will happen? Automatically you are drawing more than the capacity of that conductor. So what will happen if you're drawing more than the capacity of conductor? It starts getting heating up. So it starts getting heating up, it melts the insulation, then it leads to short circuit. Then unsafe, improper use of equipments and working on moving or dangerous equipments, necessary exposure to the danger, and not using proper personal protective equipments, and improper starting or stopping. So all these are the various causes which is leading to the electric hazards. If you see the majorly, I mean the top 6, one is electric shock, as we discussed, and electric burns, and fire and explosions. It is an indirect effect of electric arc or sparks, and hazards due to electric welding and cutting, arc welding and cutting, and hazards due to static electricity. This we have discussed yesterday. Fall from height due to the electric shock. Then shocks and burns or injuries from the direct contact, and they can cause accidents of three types. So how it will cause? It is about the contact. When it happens burns అంటే ఎప్పుడైతే మీకు చేతులు కాలుతాయో or injuries అంటే మీకు ఏమన్నా దెబ్బలు తగులుతాయో, it is will be for the direct contact with the circuit. So one is hold on type, ventricular fibrillation, and also respiratory arrest. So hold on type will be you'll be on the system, so it won't leave you, you'll be keep on holding you. And also ventricular fibrillation will be your nervous system, it gets congested, you are not able to breathe, or your muscle system is completely contracted. Then respiratory arrest, so resulting in you are not able to breathe properly. And also in ventricular fibrillation, your nervous system also will not function. Okay, if you see the injuries are possible without current flowing through the body also. So example, burns due to the electric arc, as I mentioned in the initial. So you need not to have contact with the electricity, but there will be a chance of burns due to the electric arc. Then due to the radiation heat and electromagnetic field, falling or injury due to the sudden starting or of the machines, equipment, and etc. So these are the other ways the electricity may cause us to the accident. And the main protections are proper fuses, switch gears, circuit breakers, earthings, and bonding. Such electrical safety precautions are highly needed to prevent accidents due to electrical hazards. The fuses, switch gears, and circuit breakers, earthings, and bondings. If you see in villages in the near the transformer, they will put a wire between for the conductors to get the supply as a fuse. So sometimes what will happen, because of overload, the fuse get failure all the times. Then they will think because of thickness of the fuse is low, it is getting tripped. So then they will add extra conductor and they'll put. So the transformer gets failed. So always these fuses, switch gears, or circuit breakers are designed for the equipment to safeguard the equipment and people from the overload or also from the leakage currents. So we should not bypass or we should not overload the equipment. Now we'll see some of the statutory provisions with respect to this electricity. So if you see in a factory act, there is a section 36A speaks about the portable electric light less than 24 volts, and also section 37 requires an effective enclosure to source of ignition, and IS standard 5216. It is for the life-saving techniques methods are followed, and part 1 and 2. And SP30, a National Electric Code, complaining the Indian standard for the electrotechnology. So these are the your reference. Take a screenshot of it. So you can, anyhow, you will get this presentation. You can refer for your more detail. Now we'll see what will happen. What are the effects of the electrical parameters on human body? The current is it's having many units, or the numbers, or the joules, or it is kWh, or milliamperes, etc., etc. If you see the first, the major hazard due to electricity is a shock to a person. It is the current, not voltage, that causes a physical damage. The voltage, it is not causes any physical damage. Voltage, it is a driving force for the electrons to flow from one place to other place through the conductors. So the main thing is the current which will make an impact on human body. Okay, not voltage. So this current is matter, but voltage is also a matter because it is a driving force, so that how much current it can pass through a person during certain amount of time. But the major thing is a current is the one which will give an impact on human body. The blood is good conductor of electricity, but the skin is highly resistive. Unless the skin is punctured, no more current will flow through your body. The blood is in a good conductor, and skin is highly resistant when it is in a dry condition. That is how the God has given us a gift. So we have our internal resistance mechanism. So until unless your skin is not punctured, so you will definitely get a shock. So it will not going to impact more. And the body resistance of each person is variable. Therefore, the effect on them is also variable. Up to 10 milliamperes, a current can be bared with a pain, and up to 30 milliamperes, chest muscles do not work and breathing stops, and also death may happen. So 30 milliamperes current can cause a death of a person. We see 250 milliamperes causes complete death. So the leakage of 0.25 amperes is dangerous for human life. Sometimes after effects are more severe than the actual shock or burns. So this is the thing which is happened. 250 milliamperes causes a complete death, and also it is nothing but 0.25 amperes, milliamperes to amperes, which will very hazardous or dangerous to our life. And if you see other effects, the electric shock is an effect of human current flowing through the nerves, muscles, heart, or organs of a body. The electric shock is a sudden and also accidental stimulation of the body's nervous system by electric current, which flows due to the voltage difference. Okay. And the current may be a DC or direct current or alternate current. DC may be maintains involuntary grip and also the live conductor which prolongs the current flow. Therefore, the victim needs to be separated by the non-metallic rod or advice. So the direct current, what will happen? It's having a tendency to hold you with the conductor which you have hold. More DC is required than AC to cause a same effect, and AC produces fibrillation. So every cycle where a DC produces only once. So fibrillation in the sense, if you see AC, this is in a like a straight. There is no this thing. So if you see in AC, it is called as a pulses. So every pulse you will get a shock. In AC, you will get more impact. In DC, you'll have less impact comparatively between both. Now we'll see what is the low current disrupts a body rhythm and also sometimes stops the heart if the time duration prolongs, but high current causes electric burns and also sometimes death. So low currents will be, it will give a less impact. The high currents, it will give a burns and sometimes a death. Now you see a shock may be happen. So what are the various reasons or what is the various causes? How a shock can happen? A shock can happen due to contact with a bare live conductor and removal of insulation on the conductor and its contacts. So whatever the conductors are there, cables are there, the wires are there. It is also happened because of the insulation have been removed. Then short circuit due to the sudden failure or short circuit current not going to the earth but flowing through the human body. So whatever the short circuit which has happened, it is not going to the earth, but it is in between. A human has been came into the picture. Due to that, he got shock. Then static charges on equipment discharges through the human body and also lightning. So these are the various the ways we get the electric shock. Now we'll see the effects of amperes. So it is about the current range of an effect of a 60 kg an average. So how it will affect? So in the left side we have the milliamperes and also physical condition of the person and what will be the impact of that shock which will get. So one is 1 milliampere, which is none. So it is not going to affect more. And 3 to 10 milliamperes, it will be a mild sensation, 3 to 10 a painful sensation. And 10 milliamperes paralysis threshold of arm. So paralysis will be, you'll get shock. Paralysis in you are not able to feel anything. You lost your sensation and cannot release the hand grip. If no grip, victim may be thrown clear. So if we are holding, sometimes it may hold you, otherwise it may throw you. 30 milliamperes fibrillation threshold 0.5% and the stoppage of breathing. And 75 milliamperes fibrillation threshold and 99.5% and heart action discoordinated, and 250 milliamperes it leads to heart and blood circulation may stop, and usually it is fatal. It is about just a breakage of milliamperes, the level of milliamperes which will affect on our human body. Now we'll see a safe distance from the electric lines. There are many regulations, rule number 77 to 88 of Indian electricity rules under 1956. There we have to provide a safety distance from this electrical lines, which is from the HT, high tension electric lines. It is also required whenever you are working closely with this high tension line on any height works. So it is obvious that a overload electric line should be allowed in a place where the public or public vehicles have to pass through for and most of the time, not at such a low or unsafe distances or clear or above ground, so that chances of touching the lines may increase. Therefore, some minimum distances from the lines are necessary. So these are the chances where the public may pass through, or maybe vehicles may pass through, or the height vehicles has to be passed through, the trucks have to be passed through. So there they make sure that some distance has to be there. So that here they have defined the minimum levels or the distances. One is across a street. One second. Yeah. If you see the minimum distance in feet and meters, across the street, a minimum voltage lines will be 19 feet. If it is in meter, 5.8. High voltage will be 20. And also along the street, it is 18 and 19, which is low, it is 18, and the high it is 19. Elsewhere in the up to 11 kV lines, bare in the sense there is no insulation on the conductor. And up to 11 kV lines insulated if it is 30. If it is a bare wire, and you can see directly, I mean aluminum wires, it is 50. And above 11 kV it is 17. And above 33 kV, 17 plus 1 for every 35 kilowatt as a part of. So it's keep on 1 feet which is going to increase. If it is above 33 kV lines, but across the or along the street, it is 20 feet. And crossing the turnway or any trolley wise, the distance above the trolley wire. So it is about above, they'll make this distance. And low and medium voltages lines, it is 4, and if the wire is insulated, or up to 11 kV, it is 6, and above 11 kV, it is 8, and extra high voltage lines, it is 10 feet. It is about the completely insulated wires. So now most of the times are in the cities, we can see this insulated lines. We are very less we can see, I mean near mostly in the public areas. So because of this thing, okay. Now we'll see where an overhead line across, or it's an proximity to another overhead line, the minimum clearance between them are provided under rule 87.3. So this is between the line to line. 11 kV, 66 kV, or 110 to 132, and 200, 400, and 800. So low and medium 2.44, or it is in 130 to 132, 110 to 132 is 3 meter. If it is 130 to 132, it is 2.4 meters or 3 meters. So these are the distances, the clearing distance between the lines across each other. So from each line, maybe we used to see the big towers for the high tension lines. There are multiple lines which are there in that. So we can see a gap between both the lines. Maybe if we can assume one is 11 kV, one is 110 kV, or one is 220 kV, based on the capacity or the conductor, they will maintain the distance. Okay, this is for your reference. You can refer this rule so that you can be able to get the detail. Now we'll see what are the safety measures for this electric works. We'll perform many activities with relating to electricity. We use electricity in our day-to-day activities in the factories. So if you see general safety measures, a proper earthing and also double earthing, general earthing for the big power stations up to 0.5 ohms. It is the resistance. They have to maintain the low resistance so that in case of any leakage, it can drain or it can discharge immediately. So double earthing will be for the, especially for the reactors, if the any sophisticated equipments, one is for the body earthing and one is for the general earthing, they used to give sophisticated equipments, they used to give the double earthing for the extra protection. And if you see use of approved insulated tools, and also the rubber mats, shock-proof gloves and also boots, tester and also the fuse pullers, and also tong. Tong is nothing but it's like a stick kind of thing. If somebody got electrocuted or somebody got shock in the panels or somewhere, it is an insulated stick. We can pull them out. And discharge rods and also safety belts, hand lamps, and also wooden or insulated ladder, and also not wearing any metal rings or chains while working with any electrical appliances or in a live wires. Switches on live lines, fused switches, and also air current breakers should be used. The switches on the live lines, how you are going to control the supply. Then avoid temporary wiring and avoid human and also chance taking, avoid left hand touching. The left hand touching, why it is? Our heart is in left side, because we can avoid the left hand touching so that we can avoid the impact of the shock. And employing a qualified and also trained electrician and low voltage 24 volts and 112 DC in hazardous area, and good insulated and tested wiring. So whatever the wiring we are using, it is properly insulated and also tested. Then isolation of a machine or equipment before use. So it is isolation nothing but LOTO, lockout and tag out. Here I want to listen from you people. Have you seen any LOTO facility in your premises?
Yes, sir.
Okay, how it works?
So the LOTO is applied for electrical means isolation work permit.
Mhm.
So whenever they are applying the LOTO, they will just once they need to de-energize all the things. Like it may be mechanical energy, so energies they will deactivate it. So after
Mhm.
that, they will apply the LOTO.
Mhm.
The LOTO will be applied, and after that they will start the work.
Okay.
Mm.
Okay, thank you. Any other inputs?
Yes, sir.
Yes, you are audible.
हाँ हरिराम बोलो सर.
Hariram.
सर लोटो वो है सर, जैसे मान लीजिए कोई हम इलेक्ट्रिकल में कुछ वायरिंग कर रहे हैं या कुछ इंस्टॉलेशन कर रहे हैं,
Mhm.
तो जो डब्ल्यू परमिट, उससे पहले परमिट लेते हैं. परमिट लेने के बाद जो साइड लाइन इंचार्ज है वो इंश्योर करते हैं बराबर है. उसके बाद लाइन टेस्ट करते हैं, उसमें कोई इलेक्ट्रिकल एनर्जी वगैरह जो लोड टेस्ट होता है, लाइन टेस्ट, उसमें करंट तो नहीं है. हाँ, करंट सारा चेक करने के बाद जहाँ से अब ये इनकमिंग आता है वहाँ पे लोटो सिस्टम अप्लाई किया जाता है उसमें,
Okay.
ताकि कोई थर्ड पर्सन आदमी कोई ऑपरेट ना करे.
Okay. It is all
हाँ,
about
अगर
safeguarding the people who are unknown. And also it is protecting the people who are working on the system.
सर ये इसके लिए इम्पोर्टेंट है कि थर्ड पर्सन आदमी कोई ऑपरेट ना करे. जो वहाँ पे मेंटेन कर रहे हैं, जो वर्क कर रहे हैं, उनके पास ही लोटो सिस्टम का जो चाबी लगेगा, की रहेगा, उनके पास ही रहेगा. जब वो उनका काम खत्म हो जाए फिर इधर जाके फिर लोटो सिस्टम हटाएंगे.
Okay, good. Yes. We'll see more how it works. Thank you, Hariram. Okay, so here you see isolation. We talk about photo. We have one topic I think on it. If I'm not wrong, we'll discuss more on that. And also work permit system as per the IS 1256. I think recently we got a work permit system 7200. I think it is to be updated. On work permit system also we have an separate training. I think in the recently we got an IS standard on work permits. If anybody have an idea, just text in Teams. Sorry, in the chat box. The IS standard number. It starts with I think 72 if I'm not wrong. Then use of a machine or equipment within their limits and no overloading. Then placement of oil type transformer outdoor. Then auxiliary rooms or battery rooms and also control rooms to be separated. And 2 exits in the each electric room for the immediate evacuation in case of any emergency. And switch gear of supply many should be separated and also from the consumer by the fireproof walls so that we can escape or we can save fire. Then generators and motors with the fireproof doors automatically activated by the fire detectors and ready CO2 type of fire extinguishers. Sorry, it is CO2. CO2 type of fire extinguishers and double communication system with the critical areas and also clear approach available for the firefighting squad. So in case if you see the clear approach available in the sense, especially it will triggers the point in the warehouses or godowns where we store our materials. Flame and shock detectors and the central fire annunciation system. Then diesel pump setup for the required fire water pressures in case of any electrical failure. And good housekeeping, including all maintenance of all electrical installations and adequate working space and also means of access around the apparatus. So in the machines and also electrical panels, at least minimum 1 meter distance should be maintained for the proper distance. And first aid boxes and also respiratory equipment is ready. A training for artificial respiration to save life from the shock and prevent higher humidity and also temperature near electric installations. Work with full protection in raining and use of flame proof or explosion proof equipment in flammable or explosive areas. So this flame proof and explosion proof topic will be morely we'll discuss in ISO 108 in chemical safety. There it is covered in detail. So wherever we have this zone 1, zone 2 and zone 0, zone 1 and zone 2 and zone 20, 21, 22 like powder, flammable powder which is available. So this zone 0, zone 1, zone 2 will be the hazardous area classification as per the ISC rules. So those we'll discuss in IS 108. Then earthing and bonding of solvent carrying a pipeline and equipment. Okay. Now we'll see types of protections. Those are the general safety measures, how it can be carried out, and a capacity and also the production of conductors and points and the connectors. Now we'll see all the apparatus conductors should be a sufficient size and strength, and they should be covered with insulating material and also placed or enclosed as prevent the danger. Whatever the insulation materials, it should be properly placed in such a way. Then the conductors in conduits, then conductors in flexible metallic tubing, or these conductors in metal trunking it is also called as bus bars, conductors with metal sheetings, then cable in trenches. These are the various type of the arrangement of which these cables will pass through. So if you see overload and short circuit protection. So here you are protecting the cables from the physical damage. Here you are protecting the circuit from the overloads. Here you use fuses, relays, and circuit breakers. There should be of sufficient braking capacity to prevent safely at short circuit currents. And arcing or a scattering of hot metal of the fuses may be prevented using improved fuses of a cartridge or any other type having any special arrangements for existing. Then arc at reduced current values. Then earth leakage circuit breakers, which is also called as ELCBs. This is also one of the protection which is in place to protect the human from the electric shock. Where it is not practicable to obtain low impedance or where a protection is afforded by the over circuit freezers, the current breakers also with the earth, and also the conductor is not adequate, the leakage protection can be achieved by voltage operated earth leakage circuit breakers or differential current circuit breakers or combined voltage operated and also differential current circuit breakers. How it works is, it depends on the current, input current and return current. If it is low or it is high, it gets tripped, and also it is also works on basis of voltage. If there is an voltage difference, again it will get a trip. So these are the various ways or the functioning of this circuit breakers. And a person in touch with the faulty equipment having electric charges on his body. So whenever he is involved in circuit, it get shock. So that here we have a switch box, and in between we have ELCB. Even the return current, it is leakage or it is different than the input, so that there you will get circuits get breaked. Then no load protection. The no load protection will be over current condition is generally known as overload condition. It should be protected by the equipment which will operate at the excess more than rated current or stop the supply. In the sense, if the equipment is having, the capacity which is running at 10 amperes. So if it is consuming more, 15 amperes or 20 amperes, because it is overly consuming, in that case, it gets tripped. So in low current condition, it said there is no low load, in the sense the equipment which is not having. Sumit, I'll tell you what is the difference between this ELCB and RCCB. Okay. And condition and also needs to be protected, because we just have 1 minute. In a following session, I'll clear your doubt. So here what will happen? The equipment which is not having any load, simply a low current or low voltage condition is said to be a no load condition, and it is also needed to be protected. Sometimes kali pump nahi ghumta hai, kali motor chalta rehta hai. So that is called as a no load condition. Simply running of electric motor without rotating the pump or generator or machine